Welcome to the Connect with BMC Helix ITSM webinar series. During today's event, you'll be able to ask questions of our panelists. The questions and answers, along with today's broadcast, will be published to our YouTube channel. Today's topic is Discovery Reporting Query Best Practices, and Vaibhav Singh will take us through this content. Over to you, Vaibhav.
Thank you, Greg. Hello, everyone. My name is Vaibhav Singh. I have been working as support engineer in BMC customer support for 5 years now. I'm specialized in discovery, Helix discovery, as well as integration issues with discovery and other products. Today, we will see how to utilize discovery generic query feature to query your discovered data. Also, we will talk about local shadow copy and the steps to query local shadow copy. Most of the concept that we discuss today will be applicable to discovery as well as Helix discovery. Here is our agenda for today. We will briefly talk about what BMC Discovery does. Then we will start with our main topic for today, that is query best practices. We will also discuss the steps to troubleshoot some common issues and some references to this topic. Let's see what BMC Discovery does. BMC Discovery is an agentless data center discovery solution that automatically discovers data like servers, network devices, storage system, etc. It also discovers configuration and relationship data and provides ways to model your business applications. BMC Discovery stores the discovered data in its own built-in data store. The discovered data can be queried by Discovery UI as well as command line. Before we start with how to query the discovered data, let's talk about where and how the discovered data is stored. Discovery uses built-in Barkley data store to store the discovered data, relationship, and other details. This data store stores simple pair of binary keys and values. All the user visible behavior of the discovery data store, such as nodes, relationship, search language, and so on, are implemented by BMC. Barkley DB manages a collection of data store files, which will be in Discovery data store file system. These files contains data entries in B tree structure. Now that we have discussed how the data is stored in Discovery, let's see how we can query it. Discovery has a query language which provides a mechanism for searching and processing the discovery data model. The basic format of this query is shown here. Let's have a quick look at each of these expressions. The query will start with the keyword search followed by other expressions. In partition is used to define the partition from where you want to search the data. We will use this expression when we talk about local shadow copy later in this webinar. Kinds is used to specify the kind of nodes, for example, host, network devices, software instances, etc. Where clause is used to define the condition to filter the nodes. The traversal is used to define a traverse from one node to another in order to access attribute and relationship from related nodes. Ordering is used to define a short order for the result. Using the show clause, we can define the attribute that we want to display in query output. The last function, processing, is used to post-process the result of a search. During our demo, we will take a few examples to understand this query language format in detail. But before that, let's talk about Query Builder. The Query Builder is an easy-to-use and user-friendly interface which enables us to define and select node kind that we want to search for, define where clause, select attribute that we want to show, traverse to related node, and so many things. Let's take a demo here to see how to use Query Builder. We will take a few examples to understand those 7 expressions that we saw in query language format. Log into the Discovery UI. Once logged in, click on Explore, then click on Data. Here you will see all the discovered details. As you can see, there are some server discovered, there are some software instances, software components, software cluster, and other details. Let's say that you want to see the details of the discovered servers. So click on the number of servers that are discovered. And you can see that Discovery is using a standard format to show the detail of the discovered servers. It includes the name of the server, the name of the operating system, hardware vendor name, virtual, and other details. Now let's see how we can use the Query Builder to get more details about the discovered servers. Click on this plus icon to expand the Query Builder. You can see that Query Builder is now visible. You can start by typing the attribute that you want to include in the query output. For example, let's say we want to include the serial number of server in this query output. So I will start by typing the serial, and then you can see I'm getting the option to select the serial number. From the column section, you can select the added attribute and drag it up and down to change the position of it. For now, I'm going to put it just after the operating system. We can also change the name of the attribute as per our requirement. So I'm going to name it something like host serial and hit enter. We can also remove the attributes which are not required in this query. For example, let's remove partition, cloud hosted, and scanned via. Once we have added all the additional attributes that are required to be displayed in the query output, click on the refresh result, scroll down, and you will see that the query output is now updated. It's now providing the serial number and other details like partition, cloud hosted. Those are now removed from the query. If you want to export the query result, click on all, then click on action, and then click on export as CSV. This is going to export the query output in CSV format. Let's take another example to understand what else we can do with the Query Builder. Currently, the query is providing details of all the discovered server. Say we want to search for only Windows servers. Here is how we can do that by applying filters using the Query Builder. Scroll up and go to the query constructor from the Query Builder. From the query constructor, we can apply the filter depending on our requirement. Here in this example, we want to search for all the Windows servers. So to apply the filter, we will start with the attribute operating system. And in condition, we will select something like contains, and the value will be Windows. So here we are basically defining search for all the operating systems where there is a keyword Windows. After this, click on refresh result, scroll down, and from the output, you can see that now we are getting only Windows servers. The Query Builder lets you view the raw query as well. To view the raw query, scroll up and go to the raw query section. Here you can see the query that is being used to provide this output. If you look at the query, you can see it is matching with the query language format that we just discussed. Here you can see the query is starting with the keyword search. And here we are searching for a node kind that is host. We are using a where clause where we are defining that the operating system has a substring Windows. We are using show clause to define the attributes that we want to see in the query output. Let's take one more example to understand how Query Builder can help us to query details from a related node. In this query, currently we are searching for host node kind. Say we want to include details of a related node, that is software instance, to see all the software instances that are running on these Windows host. To do that, go to the Customize section and start by typing the name of the related node. In this case, software instance. And here you can see that we are getting multiple details about software instances. The first one says software instances running on this host. So this is what we want to see. So I'm going to select that. And from the query builder, you can see that now we are inside the related node and we can select the detail of the related node. For now, let's just select the name of the software instance and click on it. You can see that now name is added into our query. Refresh the result and let's see how it looks. Scroll down and you can see that now we are getting, in addition to the server details, we are getting the name of the software instances that are running on these servers. Let's see how the raw query has changed when we added the detail of a related node. Scroll up, go to the raw query. And if you compare this new query with the query that we just saw, you can see that this detail has been added into the query. We will understand more about this when we talk about Traversal later in this webinar. If you want to save the query for future use, copy the query, then go to Explore, Query, and paste the query here. Click on Save Query, give it a name. You can also mark this query as favorite and then click Save. You can view the saved query from User Queries. You can also select the query, click on Action, and share this query so that it is available to all other users of the Discovery UI. Now let's see how we can write query directly without having to use the query builder. When I talked about query language format, I mentioned two more expressions, that is ordering and processing, that we haven't used. Let's see in what scenarios we can use those two. We will take two examples to see how to use ordering and how to use processing. To write the query directly, click on Explore, then click on Query. And let's write a very simple query here. Search, let's search the host node kind, search host. Then let's define the attributes to display. Show name, OS, serial. Now if we run this query, from the output we can see that there is no order to the operating system name. We can see some Red Hat operating system here, then CentOS, then again Red Hat. Let's say we want to sort the operating system name. To do that, go back to the query, scroll down, and from the history, select the same query that we just executed. And before we go ahead and execute this query, let's add a ordering here. The expression is order by and the name of the attribute that you want to sort. Here we want to sort the operating system. So search host order by OS, then show the name, OS, and serial. Let's run this query. Now from the output, you can see that the name of operating system is sorted. We can see all CentOS together. Then we can see all Microsoft Windows operating systems together. So this is how you use the order by to order the or to sort the output of the query. Now let's see what is processing. Click on Explore, click on Query, and let's take a scenario here. Say you want to search for all the software instances and you want to group the software instances based on their number of counts. To do that, let's run a query, search, and you can see that now I'm changing the node kind from host to software instance. Let's add the show clause, show name, And then we are going to define a processing here. We want to group the softwares which are having the same name, and we want to count how many times they have been found. So we will use the expression process with, and then we will use a function count unique to count those software instances. Let's run this query and see the output. From the output, you can see that software instances having the same name are grouped together and they are counted, how many times they have been found when infrastructure discovery happened. So this is how you can use the ordering and processing. When writing the query directly, if you are unsure about the exact attribute name, here is how you can find it. Say you want to show DNS domain name of host node in your query, but you are not sure what to type when writing the query. To find the attribute name, go to the administration section, then go to the taxonomy, and then start by looking the node kind that you are searching. For example, let's say we want to search for DNS domain, but we are not sure what should be the name when we are typing the query. So let's open the host node from the taxonomy, and on the host node you can see there are currently 82 attributes and their names are mentioned here. Let's scroll down and search for DNS domain. From here you can see that the name is DNS underscore domain. So this is the attribute name. Let's quickly use it. So in our query, let's say search host show name, comma, DNS domain. And you can see the DNS domain is now being reported in the query output. So this is how you can find the attribute exact name if you are not sure when writing it. Just go to the taxonomy, look for the node that you are searching, and then look for all the available attributes on that node. This concludes the demo on query builder and query language format. Let's have a look at few frequently used query functions and expressions: explode, search flag, and traversal. For this webinar, we reviewed many queries requested by our customer and found that these three functions are required to create most of those queries. So we will discuss when and how to use these. Let's start with explode. Normally, if an attribute contains a list, all item in the list appears in a single row in the query output. But sometimes it may be required to show the item into multiple rows. In those type of cases, explode can be used. Search flag can be used when it is required to modify the search behavior. For example, say you want to search the destroyed data. Traversal is most important and widely used out of these three. It helps us to traverse from one node to a new set of related nodes. Let's have a demo to understand how to use explode, search flag, and traversals. Let's see where to use explode function. Log into the Discovery UI, then click on Explore Data. Click on number of hosts which are discovered. Click on the plus icon to open the query builder. Remove the attributes which are not required. And let's add the detail about software instances here. Search with the keyword software instance and select the first option which says software instances running on this host. Let's take the name of software instances and add that in this query. Let's refresh the result to see how the query output is looking. From the output, you can see that all software instances are listed in single row. Now let's say we want to explode these software instances in single row. Here is how we can do that. Go to raw query, copy the query, then go to Explore, go to Query, and paste the query. Now, here is where we are going to use the explode function. We know that we want to explode the name of the software instances because currently those are getting printed in just one row. So we will use the explode function just before that attribute and run the query. Now from the output, you can see that each software instance is getting printed in a separate row. Now let's see the use of search flag. Say you want to query only the destroyed nodes from the Discovery data store. Here is how you can do that. Go to Explore, go to Query, and here we will use a search flag to define or to limit our query output to only destroyed node. We will start our query with search, then we will define a flag, and within the flag we will define a condition like include underscore destroyed, and the another condition is exclude underscore current. And then we will define the node kind, host, and then we will define the attributes to display, that is name and OS. So basically here we are using a flag where the condition only include the destroyed nodes and exclude the current, which are live node, for host kind, and print the name and operating system. Let's run this query. So from the query output, you can see that even though we are searching for host node, there are just two entries, and these are the entries of the host which has been destroyed in Discovery. Now let's see the use of traversal. Let's say you are searching for host, but in the search output, you only want to display software that are running on that host. Here is how traversal can help you with that. Click on Explore, go to Data, open the host nodes, click on plus icon to open the query builder. From the query builder, click on query constructor, and then expand the traversal section. Enter the name of the node where you want to traverse to, in our case, software instance. Select the required relationship, in this case, software instance is running on this host. And you can see here that from host node, we have jumped to software instance node. Let's refresh the result. So you can see how the result has now changed. Earlier we were getting detail about host node, but now though the query is starting from host, the details are getting printed starting with the type of the software instance, name of the software instance, version of the software instance, and then the name of the host where these software instances are running. So this is the use of traversal, where you can start from one node and then jump to another node if you want to query the data from the related node. This concludes the demo on explode, search flags, and traversals. When using the search flag, we used a function destroyed. Discovery provides many more functions like that, and those can be used to manipulate the query result. These functions help us to do value manipulation, which include manipulating the reported value. For example, changing discovered disk space size from bits bytes to KB, MB, etc. Node manipulation. We just saw an example of node manipulation where we used a search flag. By defining the function destroyed, we were able to query only destroyed host. History function include functions like create time, created during, etc., which allows us to query the nodes based on creation time. System interaction include functions which helps us to get BMC Discovery system details, like querying for user details. Out of these four, the first three are widely used. Let's have a demo to understand value, node, and history functions. We will look at few frequently asked queries by our customer to understand how query function can manipulate the data. One of the frequently asked query is how to show disk, file system, storage sizes in MB, GB in a query output. Well, this can be done using a value manipulation function called format quantity. Details of this function is documented in our doc. This function takes a value and applies a user-friendly formatting, converting the value into MB, GB, and so on. Let's see a use case here. Click on Explore, then go to Data, open all discovered host, click on Customize, remove the attributes which are not needed, and let's search for file system details that are discovered on these hosts. From the file system section, select the name of the file system and the discovered size of the file system. Let's run this query. From the query output, you can see that all file system details are getting printed in one row. We can change that by using the explode function. So let's copy our raw query. Go to Explore, Query, paste the raw query, and then let's add explode just before the file system details. So I've added the explode here. Let's run the query. Now in the query output, you can see that each file systems are now getting printed in separate rows. But still, the file system size is not in user-friendly format. To change that, we will use the format quantity function. Let's copy our raw query again. Go to Explore, Query, paste the raw query, and let's apply the format quantity function on the file system size. So let's type format quantity. The size multiplied by 1024, comma, B1024. This is the syntax of format quantity function. Let's run this query and see the output. And now you can see the size of the file system are being reported in MB, GB. So this is how you can use the function to manipulate the value. This is just one of the example. You can look into the documentation to find more functions for value manipulation. To understand node and history functions, let's take a common use case. Say you want to query all hosts, including destroyed ones, and in the query output, you want to see the host creation date as well as the destruction date. I have already created a query to fulfill this requirement and saved it in the user query. Let's review the query and its output. Go to Explore, Query, go to User Queries, and let's run the node and history function query that I created. Before we review the output of the query, let's see the raw query. So in the raw query, you can see I'm starting the query with search, and there is a flag which says include destroyed. In this flag, you can see that I have not mentioned exclude current. So in addition to the current or live data, I'm also including the destroyed nodes. In the attributes to display, I'm printing name, OS, and creation time with the function friendly time. So friendly time is going to convert the time into a user-friendly format. Creation time is the function which is going to tell us when was the host created, and it will be printed as creation time. The second function that I'm using here is destruction time, which is going to tell us when was the host destroyed. From the query output, you can see that creation time is set for all the hosts, but destruction time is only set for the hosts which are destroyed. This concludes the demo on query language functions. The Discovery UI does not provide a way to schedule queries. Also, sometime you may want to run query remotely via a script. In these type of use cases, the tw_query command line utility can be helpful. It enables us to search data from the command line. Using this utility, the search result can be redirected in CSV or XML format. Let's have a demo here to see how to use tw_query. We will also discuss how you can schedule the query using a cron job. To use the tw_query command line utility, connect to the appliance command line. For a cluster appliance, you can connect to the cluster coordinator or any member of the cluster. Once connected, you can run the command usr tideway bin tw_query --help to see all available options for this command line utility. From the output, you can see that all these options are available. Let's use few of these options and run a query using tw_query command. Let's go to the bin directory first, then select the name of the command line utility. Then the first thing we will define here a username. This will be the Discovery UI user. So let's add username equals system. You can add any other user. Just for example, I have taken system. Let's define the password. Here I'm going to put the password in plain text, but you can also use the option password file. Now let's define the option to redirect the output in CSV format. So let's use --CSV, and then let's define the path for the CSV file. So that will be --file equals to /usr tideway, and let's give it a name server.csv. So now we have defined all of the required options. It's time to define our query. So we are going to put something like search host, show name, OS, and serial. Once the query is defined, let's hit enter. And the query is completed. Let's have a look at the output of the query. So we will open the output file, cat, and then the name of the file. And here you can see we are getting details of all the servers in CSV format with the attributes that we defined here, name, OS, and serial. Now let's see how to schedule queries using cron job. Let's say we want to schedule the same query to execute automatically every day at 7:50 a.m. To do so, let's clear everything. Now let's go to the cron folder, which will be inside usr tideway etc. Once inside the cron folder, let's create a cron job. Let's give it a name query.cron. Hit enter. Inside the cron job, go into the edit mode. Let's add some comments here. Scheduling a query. Next, cron will run every day at 7:50 a.m. Now let's define the scheduling. First of all, we will have to define the minutes, which will be 50. Then we will have to define the hour, which will be 7. For day, I'm going to say every day. For month, I'm going to say every month. And for weekdays, I'm going to say again every day. And now we will add the full tw underscore query command with all the required options and query. Here I've changed the output file name to server1.csv. Now let's save this file. After this, we need to run the command tw underscore cron update to update the cron jobs. With this, the query is now scheduled. It will now run every day at 7:50 a.m. The current time on the appliance is past 7:50. So let's see the output of the query that we scheduled using the cron job. And here you can see that the query is executed via the cron job and the output is redirected to this file. You can also create a cron job using the mail to function to send this output file on email. This concludes the demo on tw underscore query and scheduling query using cron job. Let's start with our next topic for today, local shadow copy. When a CMDB sync connection is created, BMC Discovery creates a shadow copy which holds the data that has been synced with CMDB during previous sync. When data is modified as a result of scanning, deletion, or manual sync, the changes are updated in shadow copy and propagated to the CMDB. Local shadow copy can help us to troubleshoot discrepancy between discovered data and the sync data. Before we talk about how to query local shadow copy, let's understand shadow copy in details. To understand the role of shadow copy, let's look at data flow during discovery and CMDB sync. In your infra, you will have server, devices, and other assets that you want to discover using BMC Discovery. For this, you will deploy BMC Discovery appliance. Though the appliance has capability to scan server, devices, and other assets, in most cases, an outpost would be required to perform scanning. The outpost communicates with the appliance to get the scanning request. It will then connect to the target server and devices using the configured credential and perform the discovery. Finally, it will pass the discovered data to the appliance where the data will be stored in Discovery Datastore. Once the data is in Discovery Datastore and you want to sync the data to the CMDB, you will configure a CMDB connection from the Discovery UI. Discovery CMDB sync happens in 5 stages. Let's have a look at each stage. In stage 1, a root node is chosen for synchronization. The root node kinds are host, network devices, printer, SNMP managed devices, storage system, cloud services, etc. In stage 2, for each root node, a source subgraph is populated by retrieving all the relevant data from the Discovery Datastore. In stage 3, the source subgraph is transformed into a target subgraph centered around the target CI. In stage 4, shadow copy comes into the picture. As I mentioned, shadow copy stores the data that Discovery has sent to the CMDB. Discovery does this to identify changes in CI by comparing the target subgraph, which was prepared in stage 3, with the corresponding subgraph that is stored in the shadow copy from the previous sync of the CI. If any changes are identified after comparing with shadow copy, the updates are made in batches to the CMDB. Once an update has been made to the CMDB, it is also made to the local shadow copy so that it has updated subgraph of the CI for any future sync. Now that we have discussed the use of shadow copy, let's talk about the scenarios in which we need to query the local shadow copy. The expectation is that the data in local shadow copy will be same as what is present in the bmc.addm dataset in CMDB. However, sometimes you may find discrepancy in the discovered data versus the data stored in CMDB. For example, a host is discovered in Discovery, but when you go and check the same host in BMC underscore computer system class in CMDB, you can't find it there. To troubleshoot these type of discrepancy, you can query the missing CI attribute in the shadow copy to see if it is present there. If it is, then that confirms that the CI or the attribute data was synced by Discovery in the past because the same is available in the shadow copy. If CI's details are available in the shadow copy but not in the CMDB, then that means something went wrong at the CMDB side. Probably a user or a job has deleted the record directly from the CMDB side. Here are a few example format that you can use to query the shadow copy. When we were discussing the query language format, we saw an expression in partition. We will use that expression when querying the shadow copy. To query the shadow copy, we will start with the keyword search in. We will then define the CMDB partition, CMDB class, and other details. The first format that is shown here is a simple one, where we are searching for all CI in a class. The second format, we are defining a where clause to limit the query result to one CI named ABC. In the third format, we are using a search flag to include destroyed CI named XYZ. Let's have a demo to understand more about how to query local shadow copy. Let's take a scenario here. Say that out of all discovered servers, there is just one server CI that you are not able to find in the discovery dataset in CMDB. For this scenario, out of all the discovered server, we will take one of the server. For example, say this one. Apart from this server, you are able to find all other servers in the discovery dataset in CMDB. The possible root cause for this issue would be the server has not been synced yet. This will be applicable in scenarios where either the continuous sync is turned off and or there is a CMDB filter in place which is blocking the sync of this CI. If the continuous sync is on and no filters are configured and there is no other issue with the CMDB sync, then this server should have been synced to the CMDB and an entry should be created in the local shadow copy. Let's see if we are able to find an entry for this server in our shadow copy. Now from the shadow copy query syntax, you may remember that we have to look for the CMDB partition. To find the CMDB partition, I'm going to run a command lookup partitions. Let's run it. From the output, you can see all the partitions, but we will have to look for a partition which start with underscore sync. And for each of the CMDB connection that you have configured on the appliance, there will be one partition. On this appliance, we just have one CMDB connection, and that's why we just have one partition. So let's copy this name. Now, let's go back to the query section again. And let's write a query. So the syntax says we will start with the keyword search in, and then we will give the name of the CMDB partition. As we are talking about the server CI, which will be synced to BMC underscore computer system class, we will define the class here. BMC underscore computer system. Now let's define a where clause here. We will say where name matches, and let's copy the name of the problematic server from the previous tab. Let's put the name here. And then in the attribute to display, we will say show name. Let's run this query. And you can see we can find an entry for this server in our shadow copy. This means the server has been synced from Discovery to the CMDB, and that's why an entry is created in the shadow copy. Now let's take a different scenario. Say you are able to find this server entry in the Discovery dataset in CMDB. However, there is no serial number set on this server CI in the CMDB. The possible root cause for this issue would be serial number is not discovered in Discovery itself. Let's quickly check and confirm that. So from the Discover data, we can see the serial number is there. So let's move on to the next possible root cause for this issue. If the serial number is discovered and there is no other issue with the CMDB sync, then the serial number should have been synced to the CMDB, and an entry for that should be created in the local shadow copy. So let's create a query to see if we are able to see the serial number in our shadow copy. Let's go back to the query tab. Let's open the query section again. And in the same query, let's add the attribute serial number. You may have noticed that now when I'm typing the attribute to display, these are slightly different from what we have been using till now. For example, you can see that when I'm typing the name, the N is capital. For the serial number, I'm not saying simple serial. Now I'm saying serial number. This is because of the reason that we are now querying the data which is corresponding to the CI data in the CMDB. It's not the data in the Discovery data store. CMDB uses a different nomenclature and the attribute names are going to be different. So after adding the serial number, let's run this query. And here from the query output, we can see that the serial number is also present. This means Discovery has synced this server CI along with attributes like serial number. If these details are missing in the CMDB, then something has gone wrong at the CMDB side. When working with these type of issues, if you see that the issue is impacting only few servers, then the recommendation is that you can destroy those servers and rescan. That will trigger a fresh sync of this CI into the CMDB, and the details should be available after that sync. However, if the issue is impacting many more servers, then the recommendation is that we go ahead and run a full resync. Let's take one more use case to understand the use of search flags when querying the shadow copy. Say there is a server CI which is destroyed in Discovery, but when you check the CI in Discovery dataset in CMDB, the attribute mark as deleted is still set to no. So what happened? Why didn't Discovery send mark as delete equal to yes for this CI in the CMDB? Again, we can query the shadow copy to see if Discovery has sent this flag to the CMDB for destroyed CI. Let's start by searching the destroyed server CI in Discovery. For this, we will run the same query that we executed when discussing the search flag. I have already copied the query here. Let's run it. So there are two servers which are currently destroyed in Discovery. Let's copy the name of the first server and we will use this one to check the details in the shadow copy. In the next tab, I have already created the query, and in the query you can see that I'm searching with the flag include destroyed in the CMDB partition. The class name is the same as the previous query, that is BMC underscore computer system. Where name matches, I'm putting the name of the destroyed CI, and then in the show clause I'm printing name, and using the destroyed function I'm printing whether Discovery has sent mark as delete equal to yes to the CMDB or not. Let's run this query. From the query output, we can see that Discovery has sent mark as delete equal to yes for this destroyed CI. But if this attribute is still set to no in the CMDB, then something has went wrong at the CMDB side. To fix this, you can manually sync the destroyed CI to the CMDB. Here is how you can do that. Open the destroyed CI and let's do sync to CMDB. If this issue is impacting a lot of destroyed CIs, then you can run a full resync from Discovery. This concludes the demo on how to query local shadow copy. BMC support has created several troubleshooting guides based on the commonly raised support cases. In our documentation, you can look for troubleshooting section to find these guides. Let's look at few common issues which you may encounter when running a query. Say the query fails with an error like some Corba error, illegal characters, or some syntax error. The probable root cause for these type of issues are missing comma between attributes to display, you are searching for an incorrect node type, or you are using incorrect functions or character. To fix these type of issues, check the query syntax. The next common issue is that when running the query, the output is no result found. This happens if you are searching for an incorrect node type, or simply the node you are searching or the detail you are searching is not discovered or available in the Discovery data store. To fix this, check if the node type is correct and make sure that the node you are searching has been discovered. Here are some knowledge articles that you can refer for more details on the topic that we discussed today. The first knowledge article provides more details on Discovery data store. The second knowledge article provides its steps to write a generic query. The third knowledge article explains how to schedule query using cron and tw_utility. And the last K provides more example and steps to query the local shadow copy. Here is the summary of what we discussed today. We talked about Discovery data store. We discussed query builder and format. We saw use cases around commonly used query functions. We discussed how to schedule query using cron job and tw_query utility. We discussed local shadow copy and the steps to query it. And we reviewed troubleshooting steps to identify why a query is failing. This concludes my presentation. Thank you for your time. Greg, over to you.
Thank you. And now I'll take us through the self-help in contacting BMC. The YouTube channel where this webinar will be posted is listed here. It contains past webinars as well as a rich set of how-to videos. The Connect with BMC Helix ITSM and Remedy webinar schedule is available at this community's link. As always, contacting technical support via web, phone, email, and these social channels is available. At this time, that will conclude this webinar. Thank you for attending.